Welcome to In the Workshop. In this episode I will be making a Backgear shaft cover for my Smart Brown Lathe. This is an excellent old lathe with very few problems, but this one is a slight problem. Someone's been extremely heavy-handed and cracked the casting around this bush in the headstock which supports the Backgear shaft. The casting is cracked and there's an oil leak from the end of the shaft anyway. I'm going to make a special cover that fits over this damaged part to seal the oil leak and make it look better. So it's over to my Boxford lathe, and I've taken the chuck jaws out of the chuck, and instead I'm fitting the outside jaws to support this large billet of steel. I'm tapping it with the hammer to make sure it's square on the chuck jaws. So here we go. Oh dear, this doesn't look very good. What is happening here? What's gone wrong? Okay, I did it on purpose. I've put the chuck jaws in the wrong order. It's very important when you're using a self-centering chuck to make sure you fit the jaws in the correct order. Each jaw is clearly numbered. On this chuck, the slots are not clearly numbered, but one of the slots has a mark on it, and that is where jaw number 1 fits. After fitting jaw number 1 in the right place, using the chuck key, you rotate the scroll and add jaw number 2 and jaw number 3. If you have a 4-jaw self-centering chuck, the same rule applies, but on an independent 4-jaw chuck, where all the jaws can be moved individually, it really doesn't matter. I tapped the piece into place, but obviously the back of this piece was not fully square. It doesn't really matter, because once I start machining the part that's rotating, it will all become very true. Here's a useful tip. When first fitting a rough lump of steel into the chuck, use the cutting tool from the inside outwards. If you do it the other way round and suddenly the tool meets a very irregular surface, the carbide tip could be damaged. But don't forget, this is a home workshop. I'm not applying industrial techniques. This piece of steel is a chucking piece. It's what's left after someone has machined a piece of steel this diameter in a much bigger lathe than this. It's annoying really. I have the Smart Brown in the workshop, but it's not ready for service yet. If it was, it would make short work of this job, but instead I'm using my smaller Boxford lathe, which does the job, but you have to be gentle with it. For the initial rough cut turning, I'm actually using the point of a chamfering tool, and once I've taken the first cut, I changed the tool back to the normal one that I used at a slight angle, as you can see here, and the finish I'm getting on the work is quite good. In this part of the clip I'm facing across the front. The finish is very relative to the speed of feed and the speed of rotation, and the finish here is quite acceptable for what I want it to be. This is not a precision part, and besides it's going to be painted, so any lines in the work will be useful to key the paint. After facing across the front, I took a longitudinal finishing cut all the way down the work. From now on, to get through this sequence in a reasonable time, I'm increasing the speed of the video. This is running at 4 times normal speed. Very quickly I end up with the quality of finish that I need. Now it's fun time. First of all, using a centre drill, I drill a hole in the centre of the work. Then I use a much larger twist drill to drill a hole in the centre about ½ an inch deep. I've applied some of the cutting lubricant, and at the moment it's deceptive because I'm running at quite a slow speed, although in the video this is speeded up to 4 times normal speed. After drilling the hole to the depth that I require, it's now time to use a boring tool. This is a very long and, dare I say it, boring job. It takes quite a while to do. When cutting metal on a lathe, either internally or externally, you have to only work up to the capabilities of the machine that you're using. I've still got quite a fair way to go yet according to the caliper. Periodically I attack the work from the inside out, just to make sure I don't end up with a lot of ridges. This boring tool is a negative rake tool. As you can see, the tip slopes towards the part that's been cut. It's very good at removing metal and you get a good finish, but you do have to put a little bit more pressure on to push it into the steel. If you only have a small lathe, then there's a good chance you will run into problems by using negative rake tip tools. But on my Boxford lathe, this tool seems to work very well. Eventually, bearing in mind that this video is very heavily edited I arrive at the size that I need. But now I have a problem. In the Boxford lathe with the small parting tool, it's going to be difficult if not impossible to part off a piece of steel this size. Instead, I remove it from the chuck and I need to apply some ingenuity. I'm going to use my bandsaw to cut the piece of steel. The only problem is, this piece of steel will not fit in the vice jaws, so I've had to just use some animal cunning and ingenuity. You can see that by using 2 pieces of 1/4 inch bar and another piece of steel that spaces the 1/4 inch bars, I can easily extend the clamping capability of the vice jaws. And it's cutting quite well. I'm just applying some oil to make it cut even better. After performing an oil change on the Smart Brown Lathe, now I've got quite a lot of oil that will be good for general jobs like this. I filmed this sequence in real time, just out of curiosity, and when I look at the video clips, the entire raw sequence lasts for just over 30 minutes. And to help prevent any viewers from accidentally slipping into a coma or feeling the need to phone the Samaritans, I've definitely edited this to a reasonable watchable length. Here's the final part, and the cut is now complete. Over now to the Boxford, and I'm fitting the other jaws back into the chuck. Making sure that jaw number 1 fits into slot number 1, number 2 jaw into slot 2, and number 3 jaw into slot 3. And by doing that, the jaws should be true enough to hold the work. I'm going to hold the part that I've made using the outside edges of the chuck jaws like this. It's important to remember to tighten the jaws in the opposite direction when you're holding from the inside edge. I faced across the front and I cut a bit of a recess just to make it look fancy, and then I chamfered the edge so it wasn't sharp. Here's the original crack fitting, and now it's been revolutionised when I fit my special cover. I use silicone rubber to hold the part in place, and here you can see that some of it is oozed out. But after attacking the part with a cloth, it now looks like this. It's a definite improvement, and no longer will oil leak from this point into the chip tray. And as you can see, it generally does look a bit better. And once I've painted it the same colour as I painted the rest of the Smart Brown lathe, you won't even know it's there. That's it for this one. Stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.